Hi, everyone. You having a good time? Cool. Well, this is a fun, relaxed, kind of inspiring talk, hopefully. Hope you get something out of it. Now, the future is in machine learning, and that's not hyperbole. People are fearing losing their jobs to technology and robot uprisings, artificial intelligence changing their worlds, and I do see a changing of the world we live in. I think we're on the cusp of change. The way we work, no matter our industry, is going to be fundamentally altered. But this doesn't have to be a bad thing. Our computers are not our evil overlords. They're our new best friends, our greatest collaborators. And machine learning is giving us the power to expand our horizons. The future of art is also in machine learning. Art is seen as an exclusively human avenue of self-expression, but the art we're starting to produce with machine learning shows limitless potential for those willing to grasp it. A few years ago, if you'd asked me if I would be working with machine learning and augmented reality, I would have no idea what you meant. But telling me I was working with learning networks that could produce art with me, and mobile technologies that reveal the truth behind those artworks, that's incredible. And now, the technology just moves so fast it's almost impossible to keep up with. I'm completely obsessed with machine learning. But for me, it's the art and the frivolous projects that really delight me. Janelle Shane is an amazing example. Have you all heard of her? She's just incredible. She's known for using neural networks to create paint samples and name pets. She also calls for crowdsourced input for her neural networks creations, whether it's D&D characters or Halloween costumes or knitting or the first line of your favorite novel. She feeds the data sets into her neural nets and watches as it learns for good or for evil. Janelle Shane works with TensorFlow and Torch using char-RNN, character-based recurrent neural networks. Some successful recent projects include generating fish names and D&D characters. The real-world weirdness of humanity seems to work especially well with the weirdness of neural networks. Botnik is another fun example. They train predictive text keyboards on scripts, books, and advertising, and have people work with those keyboards to create entire show scripts, Halloween tips, ads, romance novels, even Harry Potter. I've worked with Botnik. Anyone can join their Slack and become a contributor. And what's interesting about these is that while the content possibilities are driven by a computer, the humans are pulling the strings. It's often advertised as, oh, this is an entirely generative novel. It's not. It's humans working with predictive text to create something amazing. It's a collaboration. And because all of this technology is available to anyone with a GitHub account and some understanding and patience, we're seeing the highbrow combine with the lowbrow, the sacred and the profane, the serious and the ridiculous. I feel that this openness, this sharing, is what leads more and more to breakthroughs. Not only are we collaborating with our computers, but we're collaborating with people all over the world. Take Google Deep Dream. On its own, as an algorithm, it's fascinating to computer scientists. It uses cellular-style thinking to conceptualize what it sees and draws comparisons with things it's been taught. The images created by the professionals at Google Research Labs are something to behold. Each one gains in complexity the more it's put through the system, and the more Deep Dream reinforces its own assumptions about what it's been taught. If Google had left it at that, if they'd released some of the images and showed what they were doing, people would have been momentarily curious, but it wouldn't have gone beyond that. But Google released the open source code and enabled everyone with the understanding to be able to use it. And then developers created tools to allow lay people to create their own images with minimal computer understanding required. This collaboration is at the heart of cyber art. Deep Dream has become a tool used by millions to create disturbing imagery of their very own. The process, the sharing, the discussion around the images is part of the art, not just the works themselves, but the possibilities inherent in allowing a computer to dream psychedelic images of your work. Everyone has the power to create these images. Just as everyone has the power to pick up a paintbrush or take up a camera, what they produce depends on their understanding and whether they use the standard options or work with the code to create something truly unique and startling. Cyber art can be a great equalizer. The tools are available to everyone, but what you do with it, that's the question. That's what transcends the work. Like all art, it's easy to start, but difficult to master. Deep Dream was a leader in the way we look at generative art and machine learning. It made machine learning an accessible, visual thing for everyone to embrace. It was the first snowball in an avalanche that started a lot of work in neural network imaging and art. I love that frog. A Neural Algorithm of Artistic Style by Gattis, Ecker, and Bethke is the seminal work on style transfer algorithms, building on the capabilities of Deep Dream, but with the capacity to change one image into the style of any other. They're also the creators of the website deepart.io, where laypeople can come and use their scripts in a web-friendly interface. Historically, I've used a Torch implementation of this concept called Neural Style by J.C. Johnson. It allows me to see every iterative stage and fine-tune my parameters to get the results I'm after. I now use a Python version on the TensorFlow framework. Style transfer has also been one of the focuses of Magenta by Google in TensorFlow. On the face of it, style transfer is a really kitschy and basic concept, a pastiche, as Magenta refers to it. Early into my research, I was asked what made it different to a Photoshop filter. And if you consider it in terms of the feed-forward mobile app Prisma, it's quite similar to a Photoshop filter in many ways. A Photoshop filter is predictable. It's reliable. The results have been fine-tuned to a degree that everyone can use them effectively. In Prisma, the style images are curated, so the results always come out well. You can always tell a Prisma piece because there's so little variation in the results. But the difference between style transfer and Photoshop is that the image is broken down by the algorithm into its components, and it's rebuilt into something else. It starts with comprehension, understanding the components that make up the image using an image classifier. Then deconstruction. It breaks the image down into a more malleable state. And then finally reconstruction, where the image is built back up using new components, incorporated with the understanding and comprehension of the previous two stages. Neural style is iterative, with multiple levels building on each other, reinforcing concepts and building on the stage before. Watching the iterations in an animation, you can see how the works evolve as they're broken down and rebuilt. Each work is new and different in some exciting way. With neural style, I can't ever say what the results are going to be or what will work best. As I progress in my machine learning knowledge and research, I'm learning to select the best styles to transfer and the ideal parameters, even the better neural networks to run it through. But my first few attempts were disastrous. Encouraging, but disastrous. And over time, I learned more and refined my processes further. Luckily, I document all of my parameters and all of the processes for every step of the way so I can recreate any image at any time. I really learned how to document doing these projects. I can't say why one work will end up being more successful than the other. That's part of the mystery of art. Success, for me, isn't always in a perfect style transfer. It's indefinable. Like art, I just know it when I see it. The most exciting moment for me is when the neural network adds a color that's not present in either the render by me or in the style image I use to define it. The unexpected and unpredicted outcome is fascinating because I look at the image as a whole, but the algorithm treats every pixel the same. They're all as valuable as the one adjacent. So this is a render I transferred using a deep photo semantic style transfer. The deep purple here isn't present in the render or the photograph of a stream I took. It's an addition added purely by the computer. I know it's probably a result of a color aberration in adjacent pixels, some kind of compression aberration. But it chose that color. It decided to emphasize it. And that is when a piece becomes more successful to me. A splash of digital purple or magenta in a nature-inspired work. That moment I see something like a random color bloom, that's a moment I'm proud to be an artist working in this field. There's a sense of rightness, of working collaboratively with my computer as an artist. We're seeing truly incredible works starting to emerge now thanks to generative adversarial networks. The artworks created are starting to fool people into believing they were created by hand. Rutgers Art and Artificial Intelligence Lab has published a paper discussing how they trained a GAN with different painting styles to create a creative adversarial network, then put together a panel of people to compare and judge works made by humans for Miami Art Basel, the premier contemporary art fair in the US. And it's comparing those to artworks produced by machines. In the end, users believed that 53% of the creative adversarial network images were made by people, as compared to only 35% of the generative adversarial network images, and interestingly, only 41% of the Art Basel works. Where things get interesting, however, is when respondents were asked to rate how intentional, visually structured, communicative, and inspiring the images were. They rated the images generated by the computer as higher than those created by real artists, whether in the abstract expressionism set or the Art Basel set. What we're seeing here is art created by computers rated higher by humans than works created by hand. Imagine what we'll see when human artists embrace working with machines even more. Generative adversarial networks run in a similar way to artistic critiques or code reviews. A producer creates something and it is immediately critiqued by its adversary, like academia dialed up to 11. But neural networks don't have feelings, at least not yet, so we don't have to worry. This process is repeated over and over, and the machine learns the best way to produce the work to fit the definition and criteria. In this way, we may discover more about what makes art art. GANs are the very definition of I know it when I see it. But without emotional or political bias, it can determine artistic quality for itself. While in this way we may learn more about the artistic process and development, we may also run the risk of GAN producers restricting themselves too much. Like an artist who finds out that only one thing sells and produces nothing but that for the rest of their career, like Thomas Kincaid. We need to strike a balance between encouraging imagination while still allowing it to exist in the loose category of art. We stand on a new precipice of artistic discovery, just as we did after Duchamp declared the artist of the future will merely point his finger and say it is art, and it will be art. And while many disagreed and were outraged by his works, it heralded a new way of looking at art. We are yet again facing a new way to look at art and art creation. The primary creative platforms for artistic development are Caffe from Berkeley AI Research, the benchmark source for many pre-trained models, and training your own convolutional neural nets, and TensorFlow's Magenta platform, which has a number of musical options, in addition to its own style transfer. The idea of music being composed by an AI is often easier to conceptualize than visual art. Music is highly mathematical, with a series of absolute rules that can be programmed in. There are no such rules for visual art. Music is mathematical. It's algorithmic. It's the essence of mathematics made human. So why do people have difficulty when they're listening to computer-generated music? We gain empathy with the performer of a piece, but the composition itself still follows the same rules. Do any of you watch Voyager, Star Trek at all? Yay! A couple of nerds in the audience. Excellent. So you might remember this episode. For the rest of you, there was an episode of Star Trek Voyager where the Doctor was performing opera for aliens. He's a hologram. And this sounds really far-fetched, but bear with me. The aliens had never heard music before, and they were overwhelmed with the mathematical possibilities. One started to compose her own work, and the Doctor was duplicated and his vocal capacity reprogrammed to fulfill the new requirements. All of the aliens loved the new composition, but the humans could not enjoy it. It was too alien, too different, too far beyond the constructed rules of music as we know them today. Now, I see AI music like this. Many people are uncomfortable because it has the potential to move beyond what we know of music. We can program a neural net with the rules and forbid it to stray outside, and it'll do passable new works that will echo some composers, but it won't really quite make it. Or we can dial up the imagination and allow the rules to be broken and see what new ideas form. The best music comes from knowing the rules and breaking them in interesting new ways. That's how we get blue notes and syncopation. In art, any form of art, rules are made to be broken. Platforms like Amper, Watson, and Magenta are allowing artists to collaborate with AI to create truly interesting work. Machine learning moves pretty quickly, and I believe if we can keep up with our collaborative partners, we will create some truly outstanding things. I believe we still need a human vocalist at this stage, but one day, music may surpass our physical capabilities. And with no programming knowledge whatsoever, we can use style transfer with deepart.io, create music with Amper, create hallucinations with Deep Dream Generator. If that piques interest in the possibilities of machine learning and you have understanding of command line functions, then suddenly your world is opened. You can install Caffe and Torch for style transfers and image training and recognition. You can install TensorFlow and Magenta, create music and style transfers, and suddenly you have more control. Rather than just allowing a website to set the tone, you can create anything, and you can change the parameters to fulfill your own model of success. One of my favorite aspects of machine learning is when the tools to create are released into the wild, when the information is disseminated to the point where everyone can explore and create their own works, when AI leaves the lab and the internet gets involved. That's when the most exciting developments start happening. The trend I see over and over is when technology comes out and it goes viral because people discuss how creepy it is and how grotesque. They see the silly and the weird, and they're satisfied, if not comforted, and seek to learn more. Then further development takes over, and artists become involved. This previously creepy and silly technology moves into the realms of higher art. I love seeing the frivolous, creepy, and bizarre uses of machine learning because I feel that's where the greatest progress into human styles of thinking will be made. Puppy slug is the term given to the bizarre creatures that Google Deep Dream comes up with. A horrifying melange of psilocybin-induced critters with too many legs and dog heads and bird bodies and snail shells and eyeballs. Deep Dream was many people's introduction to machine learning, and they used it to create nightmarish selfies and food pictures. Most people online use the default convolutional neural network Caffe model Zoo. A CNN can only know and can only use what it's learned and what it's been trained on. And Caffe Model Zoo is trained on animals. In fact, there are so many dogs and birds in it, it can't help but be reinforced. In a way, it has confirmation bias. It sees something, and each layer confirms and builds on it. Is that a dog? Oh yeah, totally, that's a dog. But like, a dog with bug legs? It's like a group of stoned people looking at clouds and agreeing with each other. It misses the big picture and only looks at the small parts and builds a story based on those sections. Style transfer, on the other hand, has resulted in fewer people being horrified to look at their social media feeds. Some users have created some truly excellent machine learning-based artistic creations, like these dinosaurs made from fruit and flowers by Chris Rodley. They were made using deepart.io, and went viral last year, introducing the concept of style transfer to thousands who had never heard of it before. These works were made by crossing a book on flowers or a book on fruit with a book on dinosaurs, and successfully carry the essence of both across. They exist in synchronicity together. Reddit users, however, have found this style transfer more unsettling. It's of Napoleon crossing the Alps, and it's highly successful, but has also been hailed as highly creepy due to every element being comprised of unexpected fabric folds. Now, this is one of my hands-down favorite things. It's a Christmas carol composed in 2016 by showing a recurrent neural network a picture. The internet blew up with tales of its creepiness and proof of how AI is going to murder all humans. But this was an independent creation by a machine after being shown a picture. It's a reaction to a stimulus to create something different. It's inspiration. It has some issues. It interpreted the decorations on the tree as flowers, but there are glimmerings of Christmas carol sentiment appearing around the edges. The synthesized voice is probably the biggest impediment to the empathy behind the project. This work was created in Berkeley AI Labs as part of their neural network, a neural karaoke project, and as part of a greater project involving composition of pop music and story singing such as this. The reaction to this is almost as fun as the work itself, and that's part of the controversy in machine learning-based art. The online nature of the work opens it up to response, and the response becomes part of the work. Apps such as FaceApp are a fascinating look into mobile-based applications of machine learning. They're a frivolous use for sure, but they provide insight into notions of beauty, gender, and aging, and the forced smile. They go beyond Snapchat filters and Photoshop morphs to fundamentally change aspects of the face and create as seamless a result as possible. Sadly, I don't know as much about FaceApp's underpinnings as I'd like. The speculation is that it uses a conditional generative adversarial network, and I've surmised, based on a lot of testing, that its main dataset is CelebNet. But unfortunately, that's it. I'd love a chance to go further with the code and implement my own ideas. I've played extensively with it as it is, seriously. But to be able to investigate the technology beneath and use it beyond the mobile app environment would be wonderful. The results from FaceApp that have gone viral have been toys, statues, and paintings. And people seem to be grossed out by the app forcing a smile onto faces. But if you look to how it attempts to match the style as well as the smile, that's where it really starts to become successful. MugLife is the latest facial manipulation app offered by NVIDIA. It's an attempt to make a 3D a GIF generator. It uses machine learning to detect facial data, then creates a mesh overlay with your photo as an overlaid texture. From there, you can manipulate it yourself or use their preset animations. It was trained using cuDNN to analyze photos and understand the components that go into a photograph of a face: the lighting, the features, and the texture. Using that data, it's able to identify facial features and overlay the 3D mesh to enable warping and animation. On the face of it, it's a really, really silly concept. And the user interface and the meme content do not inspire a lot of confidence in the back end. It works well on subtle animations, but not very well on large ones or with people with glasses. But the technology behind it is exceptionally cool. There's a lot going on behind the seemingly banal interface. But just like with FaceApp, MugLife works particularly well bringing art to life. The exaggeration and ridiculousness work particularly well in this scale. I don't have any artistic applications for this yet, but the app's only been out for a few months. However, I have been lucky to get my very first fail with MugLife, sorry. I find that with anything involving machine learning, the fails are almost as interesting as the successes. This is a photograph a friend took of a statuette of baby Jesus, and I couldn't resist running it through. The mesh applied poorly in this case due to the angle of the face, and somehow the mouth has ended up in the neck to create a gaping maw. It's also supposed to say, "You mad, bro." But for some reason, the text has also failed, creating this really bizarre Simlish caption. This one GIF gave me so much hope for this app. Pix2Pix is another machine learning application that has gone from creepy to wondrous. Pix2Pix uses conditional adversarial networks and is set up to translate images from one thing to another. That may be using style transfer, coloring black and white images, changing day to night, generating a city from a map. It can also synthesize high-quality photographic images from semantic label maps. But that isn't what it's best known for. Although this is absolutely game-changing technology, this is incredible. It's best known, however, for filling in sketches with photographic data. This last example went viral online when a web interface for the system went up for everyone to sketch cats and shoes and handbags. There was even very briefly a portrait one that's been taken down, unfortunately. I wish I could play with it. Again, like Deep Dream, everyone responded to this creepiness, the horrible things that could be made and shared around to laugh at. And it is so much fun to play with. The cat one is just a joy. But where many see a creepy and short-lived option for entertainment and nightmare fuel, artists such as Patrick Tressett are seeing the possibilities for high-end art. This GIF is from Patrick's work with Pix2Pix, training his own conditional adversarial network in a series of sketches produced by robots during an installation, and the photographs of people sitting for their portrait. He then produced a sketch, submitted the video to the CAN, and we can see the effect. The result is otherworldly. It's almost painterly. With a decidedly digital feel, it takes on a sense of evolution. This is an example of taking something that no one expected to have any artistic merit and exploring the high-end artistic possibilities. Each work is a unique thing, but viewed together as a progression, it's a new exploration of a collaboration between human and algorithm. Turkish painter and illustrator C.M. Kozman and PhD computer science student Roloff Peters teamed up together to run Kozman's surreal demonic images through Deep Dream. The works were called demonic imagery from medieval text. Far from creating the demonic imagery itself, Kozman's theory is that it works off the same data as we do, and it summoned the images for itself based on that knowledge. These works are engaging on their own, but they appear to gain depth and an unsettling nature when parsed through Deep Dream. They take on an additional level of emotional engagement that I feel pulls me into the work more. They gain elements of Bosch creeping around the edges. The output of Deep Dream defies understanding most of the time. It gives us whispers of what it might be like if a computer started to think. Knowing only what it knows from a dataset, it gives us a glimpse into an alien brain. Mike Tyco is one of the better-known artists working with machine learning. These Deep Dream Inceptionism works were created using random noise and neural networks trained on patterns in cities by the MIT Computer Science and Artificial Intelligence Laboratory. Since creating these works, Tyco has been working on his series of portraits of imaginary people. First using Deep Dream-style backpropagation approaches, then moving into generative adversarial networks. He uses a deep convolutional generative adversarial network to generate faces on a tiny scale, and then a stack GAN to upsample the different parts of the face according to a generated face map. It merges them together in a high-resolution format. This tiling technique uses similar technologies to Pix2Pix in its texturing, using semantic mapping. The final result is breathtaking. The faces are human yet otherworldly, with a painterly aspect to the texture that gives them a sense of a soul. Now, bear in mind the results of Mike Tyco's works created in June 2017, and look at these portraits created by NVIDIA in October. They also use generative adversarial networks and the full weight of NVIDIA's research team. They're made for different ends, but these are generated celebrity images. They do not exist. This is how fast the technology is moving. It's staggering. The technology is incredible. But does it have the emotional impact of the Tyco works, of the Tressert video? I realize these aren't supposed to be artistic and therefore are not necessarily supposed to have an emotional reaction, but we need to consider the why when we're looking at technology like this. What purpose does it serve? Tyco's portraits received complaints of uncanny valley, but I've seen no such response to the Celeb A images. Why is that? Is it an emotional reaction and therefore a key element of the artistic process? Is it necessary? I admit I don't actually feel or notice uncanny valley, so I've done what any normal nerd does when confronted with something I don't understand, and I've researched it extensively. People mention it with regards to my own work. In fact, one professor during my master's actually had to sit down. She was so discomforted by the pieces. Uncanny Valley has ruined box offices, with people complaining about movies like Final Fantasy and Polar Express. It's become a thing to move away from, without examining enough of the why and how it works. I argue that if we move too far away from it, we get emotionless works, like the Celeb A images. They may be very proficient, but not necessarily emotionally charged. Artists always need to consider engagement with their works. Whether positive or negative, we need to have a reaction. We need to engage the viewer. Digital art can run the risk of being too sanitized in the fear of the uncanny valley and therefore lose engagement, lose that hook that draws the viewer's eye. An artwork with no emotion is no art. Is a work that exists on a computer still an artwork? If we can see it on our screens rather than explore it in a museum or gallery, do we feel like it's real? Where's the art? Is the art in the code? Is it in the screen? Does it only exist when it's printed? Where does the medium lie in digital art? Is it all ones and zeros or something that transcends the foundation it's built upon? Do people see more value in a work where they can see the medium used, where they can see the texture and the brushstrokes and the touch of a human hand? Do we dismiss things on the screen more often than not? Does something exist more when printed, when painted, when sculpted? Do we conflate all our digital experiences and all our screen exposure so that they're all given equal weight? What of the work, the next Rembrandt, created entirely by computer? This work was made by using code that utilized deep learning to analyze every known Rembrandt painting until it came up with a perfect collection of characteristics that made up a Rembrandt portrait, from the gender to the posing to the lighting. The computer then sampled and processed the details to create an entirely new work based on previous works of Rembrandt, of a person who has never actually existed. Where did this person come from? If this is where the portrait is stopped, then it may have been dismissed. But the work was then taken further to produce a topographical plan based around brushstrokes and Rembrandt's specific paint application style, and was 3D printed in textured and layered inks. Is this a more valid work by this rationale? As it exists in a painted, tangible form with texture, is it a more real somehow than works that exist purely on a computer? This is an issue I grappled with as I created my recursion project. I wanted something physical, but also something entirely digital. An aesthetic display for gallery hanging, but an exploration of machine learning and an analysis of post-gender concepts in a digital space. For me, augmented reality was the solution, allowing me to bridge those worlds. I craft 3D models in DAZ 3D and Blender. The works were rendered in LuxRender, which is a physics-based render engine that emulates the way different surfaces interact with, absorb, and reflect light. I use lighting based off photographic rigs to create the environmental lighting I need and tailor my materials to get the most realistic renders possible. From there, I take the final render together with the original inspiration behind the work, such as archaeological artifacts, paintings, things I turn up in my research, and I use neural style to create a machine learning-based interpretation of that work. I also use machine learning to create laser cuts to work with the augmented reality, so we have it going both ways. We have a recursion, there's the render that takes it into an interaction, and then the abstract that takes it back to the render. The simplicity of this interaction shouldn't detract from what it is. When you hold your phone up to a work, the piece fundamentally changes. And when seen with its partner fretwork, where it begins from an abstract space and loops back to the original render, you start to gain an idea for the notion of transition. I didn't want to create a work on transness where the figures transition physically. This work isn't about that. It's about being who you are, how your inspirations and the things you see become part of you, and how when you look at yourself, you see parts of everything you have consumed visually coming together. And that is why machine learning is such a wonderful tool for artists to use. Because everything we absorb ends up in our work. Knowingly or unknowingly, we train our minds and spit out the results. Some are resolved and well executed, and some are gibberish. But our art is the product of what we absorb. Enter neural networks and the ability to train it in specifics, art from a given time, pictures of flowers, colors, shapes, faces, smiles, and we gain the power to collaborate with the computer in incredible ways. This is an animation I created using a render, an animated render created in a series of images, and then a style transfer that iteratively did each one in a higher progression of content and style. So we get a more resolved image with each one. The questions that arise when looking at these works is, can computers create art? Are these works a digital art, or they're just a flash in the pan? Are they merely a kitsch development of some cool code, or a new way to look at the way art is made? Where does the art lie in these works? Is it in the collaboration, the code, in the works that are produced? Many art forms are similar. They rely on the artist to control as many of the variables as possible, while maintaining the freedom to allow the work to take shape. When the brush, in this case, is an algorithm run by a computer accessing the sum total of a neural network's knowledge, then the output is chaotic, to be sure, but able to be controlled through knowledge and expertise. An artist working with these tools still has to learn to use them effectively to produce something unique, just as a painter or a photographer would. As the old programming axiom goes, garbage in, garbage out. Neural networks at their heart are mimesis. They're an imitation of the human brain, developed to try to think like ours and make connections. The truly disturbing thing about it may be that we do not want to acknowledge that it is getting closer to the way we process thoughts and images. Whether it is mimicking the style of artists, hallucinating strange beasts, or creating a person we've never seen before, computers are drawing closer to mimicking the way we create art, to duplicating the styles made by human hands and the connections we see. We appear to be drawing ever closer to replicating the way artists view the world. If we can teach computers to see the way we do, then we're getting closer to them creating the way we do as well. If we can replicate that, if we can work towards duplicating the processes in digital art and using these methods to augment our own creative works, because when an artist is combined with an artistic computer, the possibilities inherent outweigh the capabilities of each individually. I believe there's space for the ridiculous frivolity of the FaceApp selfies, as well as the beauty and surprising complex structure of the Tyco works. There's room for artists to collaborate with code to create something in between, and room for the computer to do all the heavy lifting from nothing at all. The difference is in the intention. If there's an intention to create an amazing artwork, then the power is there. If the intent is to horrify or amuse, the power is there as well. The algorithm treats them all the same. It cannot tell a cat from a Kandinsky. In this way, the internet is an equalizer. The algorithms are equalizers, and anyone with the capability can produce works with this code. They can share them, disseminate them, share the code, print them to sell, or give them away as free viral fodder. Machine learning has the capacity to inspire, to fuel our work in amazing ways if only we let it, and in turn, we can seed that garden for others and for ourselves and watch the inspiration grow. Thank you. Does anyone have any questions? We've got a bit of time. Crickets. I realize I didn't actually introduce myself at the beginning, by the way, which is very lax of me, and I apologize. I'm Jay, and I'm an artist. I did my master's degree in machine learning and augmented reality, and now I'm producing exhibitions and works based on that. So, yeah, sorry about that. I should have remembered. No questions? Oh, yes, hi.
I imagine it's often, for many artists, it's difficult on a financial level to really fulfill their complete, all their art.
Oh, God, yes.
It must be even more difficult if you have a master's in machine learning, not to go and work for one of the big companies that's desperately trying to do. How does the field get impacted by the kind of technical talent vacuum machine learning skill?
That's a great question. So, how does the this industry become affected by that? It's so tempting to get a job. You know, when I finished my master's there and I had my exhibition, people were like, "Oh, you could get a job at Google," and I'm like, I have a disability, so I am spared from working a day job, but it is tempting, and I have had recruiters knocking at my door, but I like the freedom of being able to produce these works. A lot of the artists I've featured here actually have day jobs, and they're working as researchers with Google. Mike Tyco's working with Google. Mario Klingman's, I think, also working with Google. Robbie Barrett's got a grant. A lot of people have, different things. I'm the one who's working on my own with no support from a corporation, which would be a nice thing to have. Anyone else? Cool. Well, you've got plenty of time to the next one. I like to leave plenty of time for questions and for comments, so yeah. And also for people to get to the next session or whatever, so yeah. Thank you all for coming.